Good morning, students. Today we are going to see the fifth unit. The topic is center of mass for uniform distribution of masses. So in the before cases we have discussed that the mass is distributed to for the different points, and also for the 2-point masses also we have discussed. Here we are going to discuss about the how the center of mass is uniformly distributed. If we are taking a bulk object, the mass is uniformly distributed. So we are taking that as a very small mass. So del m of the body can be treated as a point mass. So what is the summations can be done to obtain the expression for this coordinate of center of masses is xcm is equal to summation of del m1 x1 and then summation of del m1. Same for the y coordinate, ycm is equal to summation of del m1 y1 by del m1, and for the z coordinate it is considered as same thing, summation of del m1 z1 by del m1. So if the small mass is taken as infinitesimally small, means we are taking this del as a dm. So then we are write this summation, that means we are replacing the summation as an integration. So that will be given as xcm is equal to, so in place of summation we are changing that summation as integral. So it is x dm by integral dm. For the y coordinate also it is same, ycm is equal to integral of y dm, and then z coordinate zcm is equal to del integral of z dm by del dm, integral of dm. So all the cases for the three coordinates we are changing that summation as integral and del dm as a dm. Okay. We are going to see the next problem, that is the example of 5.4. In 5.4 what is given means the locate the center of the mass of the uniform rod. Mass is given as capital M and length is given as small l. Solution is you consider a uniform rod of mass M and the length L whose ends will be coincide with the origin. So the rod is kept along the x-axis. We are going to find the center of masses. So infinitesimal quantity is extremely small quantity. So we are going to see the diagram. It is given here. Dx is a small quantity and x, it start from O to dx. The value is x and the length is L. So of this rod we choose this small mass as dm and the length is dx at the distance of x from the origin. So lambda is the linear mass density. So mass per unit length of the rod, lambda is equal to m by L. And then mass of the small element dm is given as dm is equal to m by L dx. Now we can write the center of mass of the equation for this mass distribution is xm is equal to integral of x dm by dm. That is, we are taking the limits as from 0 to L, x into ml by ml into dx by m. That is, we are taking that 1 by L is a constant, no variations. So we are taking the integration only for the x dx part. Mm get cancelled, so it will be out, the mm get cancelled, so no value for the m, and 1 by L is a constant, so we are taking that also out, and x dx will have the limitations of 0 to L. So 0 to L integral of x dx. So we know that how to integrate. So after integration we are getting the value as x square by 2, and for that we are substituting the limitation 0 to 1 by L into L square by 2. So xm is equal to L by 2. So as a position, L by 2 is the geometric center of the rod. It is concluded that the center of the mass of the uniform rod is located at its geometric center itself. Next we are going to see the next topic, that is a torque and the angular momentum. What is a torque? It's also called as a moment of force. So when the ability of the force to produce a rotational motion, that is the torque. So when a net force acts on a body, it produces a linear motion in the direction of the applied force. So if the body is fixed to a point or an axis, such a force rotates the body depending on the point of application of the force on the body. That is, the ability of the force to produce a rotational motion in the body is called torque or moment of force. So in our day-to-day life, plenty of examples for this motion. To mention a few means opening and closing of a door about the hinges and turning of a nut using a wrench. So the extent of the rotation depends on the magnitude of the force and its direction. So the distance between the fixed point and the point of application when the torque produces rotational motion in a body. So its angular momentum changes with respect to the time. So we are discussed that only in this session. What is the definition of the torque? Torque is nothing but, what is the definition means? Definition of a torque is defined as a moment of external applied force about a point or axis of rotation. So the expression for torque is tau. This will be symbolized as a torque. So tau is equal to r vector f vector. Tau is equal to what? R vector and f vector. So where the r is the position of the vector of the point, where f is the force acting on a body. So see here the diagram, it is clearly given. R is the position of that and f is the force acting on it. It makes an angle of theta. So this is a torque of a bridge body. So the product of this r vector and f vector is called the vector product or cross product. The vector product of two vectors results in another vector that is perpendicular to both the vectors. Hence, the torque tau is a vector quantity. So, torque has a magnitude that is Rf sin theta, and the direction perpendicular to this R and F is both will be perpendicular in its direction. So, its unit is Newton meter square. So what is the unit of the torque? Newton meter. So what is the unit of the torque? Newton meter, because force into the distance r, so that is Newton meter. So tau is equal to Rf sin theta n cap. So theta is the angle between r and f, and n is a unit vector in the direction of tau, and torque is sometimes called as pseudo vector, or as it needs the other two vectors r and f for its existence. So the direction of the torque is found using the right hand rule. This rule says that if the fingers of the right hand are kept along the position vector with the palm facing the direction of the force, when the fingers are curled, the thumb point to the direction of the torque. So that will be shown in the another diagram. I will show you. The direction of the torque helps us to find the type of rotation caused by the torque. So if the direction of the torque is out, so if the direction of the torque is out of the paper, then the rotation produced by the torque is anti-clockwise. So if the another hand, direction of the torque into the paper means that is clockwise. So out of the paper means anti-clockwise, into the paper means clockwise. So see this diagram that is given here clearly. This is a right hand rule, and see the palm and the force and R and also the tau. So the force is denoted in the blue arrow and R is in the green arrow, and the tau is on the orange color arrow. So this is the direction of the torque using the right hand rule, and which will be in the anti-clockwise means when the direction of the torque out of the paper means it is then the rotation produced by the torque is anti-clockwise. On the other hand, if the direction of the torque is into the paper, then the rotation is known as clockwise. In many cases, the direction and the magnitude of the torque are found. See the first one, it is the anti-clockwise direction, and they are giving the direction and also the magnitude of the torque, how the torques are produced. Okay, and this is the first case, anti-clockwise, and see the clockwise rotation. This is the second one, clockwise rotation. And here the F is a force and R is a we know that R vector and F vector, and it makes an angle theta, and this is tau, and that also given. Okay, so this is the thing. And what is the next thing is, So in many cases, this direction and the magnitudes are found separately. For direction, we use the vector rule or right hand rule. For magnitude, we use the scalar form. That is, the scalar form is nothing but tau is equal to or f sine theta. The expressions for the magnitude of the torque can be written in two different ways, associating with sine theta either with the r or f in following manner. That is, tau is equal to r f sine theta, that is equal to r into f perpendicular, or rs r sine theta f, that is r perpendicular into f. Both will be written as for the following manner for the two different ways. These are the two different ways for associating with the sine theta. So here the f sine theta is a component of f perpendicular to r vector. Similarly, r sine theta is a component of r perpendicular to f. So that should be shown in the figure. So f sine theta and then f and then f cos theta. So here see the sine theta that is perpendicular to it. And the same thing will be in this diagram also. See here the r is perpendicular for the f. So same for both the cases, the two ways of concluding the torque will be given here very clearly. And the next thing is nothing but based on the angle theta between the r and the f, the torque takes the different values. So the torque is maximum. So for this r and f, different values for the theta. So when the torque is maximum, both the r and the n or f are perpendicular to each other. That is, when theta is equal to 90 degree, so sine theta is equal to 1. Hence tau is equal to rf. The torque is 0 when r and f are parallel or anti-parallel. So if parallel, then theta is 0 degree and sine 0 is 0. If anti-parallel means theta is equal to 180, so sine 90 is equal to 0 and then tau is equal to 0. So the torque is 0 if the force acts at the reference point, that is r is equal to 0, tau is equal to 0. Okay, so that will be given on the tabulation form, that is a value of tau or for different cases. When theta is equal to 90 degree, tau maximum is equal to rf. When theta is equal to 0, tau is also 0. Theta is equal to 180, tau is equal to 0. R is equal to 0, tau is equal to 0. These are the different cases and different values we are getting for the tau. Next we are going to see the problem related with this, that is 5.7. If the force is applied is perpendicular to the handle of the spanner as shown in the diagram. So find the torque exerted by the force about the center of the net, and also the direction of the torque and type of rotation caused by the net. So the diagram is given, what is the position and what is that, it is 2.5 n is nothing but the force is given. So this is the force and this r is equal to 15 centimeter. So r is given, f is given. So we are going to find out these things: torque exerted by the force and direction of the torque and type of rotation caused by the net. So what is given here means the values are given, just we are going to substitute. So the arm length of the spanner, that is r is equal to 15 centimeter. So centimeter we are able to write as in meter. So that is equal to 15 into 10 to the power of minus 2 meter. And force is given as 2.5 Newton. What is an angle between r and f? What is angle? So it's like a right angle. So here see the diagram. What is this one? It's a like a right angle. So it makes a 90 degree, and that 90 degree we are taking as a theta. So what is the first one? Torque. Tau is equal to r of sine theta. So we know the value of r, that is 15 into 10 to the power of minus 2. And what is the f? 2.5. And next what is sine 90 degree? So sine 90 is nothing but 1. So tau is equal to, we are multiplying these two value, we will get 37.5 into 10 to the power minus 2, okay, into 1, that is equal to the same. And what is the unit? Newton meter. So what is the next cases means, as per the right hand rule, the direction of torque is out of the page, and then out of page means it's a anti-clockwise. So type of rotation caused by the torque is anti-clockwise, that is we already discussed. When it is into the page it is clockwise, when it is out of page is anti-clockwise. So in this case we are find out the torque value, and right hand rule, the direction is out of page, so out of page direction means it's a anti-clockwise direction. And next we will go see in the problem, that is problem number of 3.8. When the force is given in a vector form, N is applied. So N is nothing but Newton. So it's a force, no? So 4I minus 3J plus 5K is nothing but a force. It's applied at a point whose position is given. That is a position vector R. 7I plus 4K minus 2K meter. So we are going to find out the torque of a force about the origin. So R is equal to 7I cap plus 4J minus 2K, and the force F is equal to 4I minus 3J plus 5K. What is a torque? Tau is equal to R into, that is R cross F. So we know that how to write the R cross F. We are first writing the vectors, that is I, J, K in modular, and then first we are going to write the R values, that is 7, 4 minus 2. 7, 4 minus 2 is the R value, and F value is 4 minus 3 and then 5. So we know how to calculate this value. Calculate means first we are going to calculate in the modular form, means for these two, that is the I into 20 minus 6 and then minus j into 35 plus 8 and then minus 21 minus 16. So we will get 14I minus 43j cap minus 37 cap. So this is the Newton meter. So this is the torque for this value. So we are find out the torque value as such, whatever given as a vector form, and taking the modulo. You will be doing this form in mathematics, so you know how to calculate the cross multiplications. Okay, so in a modulation, so that is we are calculated here also. So next we are going to see the next example problem of 5.9. What is given here means, a crane has an arm length of 20 meter inclined at an angle of 30 degree with the vertical. So it carries a container of mass 2 tons suspended from the top end of the arm. So we are going to find out the torque produced by the gravitational force on the container about that point where the arm is fixed to the crane. So that is given as 1 ton means 1000 kg. So neglect the weight of the arm, that G is equal to 10 meter per second square. So clearly the diagram is given here. So what is an theta value 150 degree, and what is a phi value 60 degree, and what is the another value, that is 30 degree, and R is given, and the F is equal to mg. So we are going to calculate the many things from this problem, that is a force at a point of suspension is due to the weight of the hanging mass. So for that, F is equal to mg, that is m equal to 2, and then the weight is taken as 1000 into the G is 10, that we are taken, that we are concluded and calculated as 20,000 Newton. So the arm length is 20 meter. So we are going to solve this problem by 3 different methods. What is the first method means, the angle theta between the arm length R and the force F is theta is equal to 150 degree. So the torque about the axis point, about the fixed point of the arm, is tau is equal to RF sin theta. Tau is equal to what? RF sin theta. So tau is equal to 20 into R, we know that 20, F is equal to 20,000 and sin 150 degree. And we are able to write this 150 degree as 90 degree plus 60 degree. First we multiply the two values, that is 20 into 20,000, that is 40,000 into sin theta of 90 degree plus 60 degree. So when sin 90 of theta equal to cos theta, we already know in the mathematics. So here sin 90 of theta is nothing but cos of 60 degree. In place of theta, we are able to write as a 60 degree. So what is cos 60 value? 1 by 2. So 1 by 2 we are multiplied. So 2 and then this 4 will be getting cancelled. We are getting 2. So that is equal to 20,000 Newton meter. And we are able to write this in terms of power, that is 2 into 10 power 5 Newton meter. This is one method. And let's take the force and perpendicular distance from the point when the arm is fixed to the crane. This is the second method. For the second method, they are given the diagrammatic form or sin t 60 and this side r cos 60 and angle of phi is taken as 60 degree and same mg. So tau is equal to r perpendicular f, that is r cos phi mg, and cos phi, so cos 60 degree, r is equal to 20, mg is same 20,000. So here also 1 by 2. So you are getting cancelled by the 2. Same value we will get here also. So what is the next value is 22 lakhs Newton meter, that is tau is equal to 2 into 10 power 5 Newton meter. So whatever we are getting for the same value for this first case also we are getting the 2 lakh Newton meter. So we are able to write that as a 2 into 10 power 5. Here also we are getting the 2 lakh Newton meter, that is 2 into 10 power 5 Newton meter. Now we are going to discuss the third method, that is the distance from the fixed point and perpendicular distance. So what is the next method means? See here the diagram is given very clearly. Mg sin theta 60, mg sin 60 and mg cos 60, t is equal to mg. Here also same. So tau is equal to f perpendicular, that is mg cos phi, same 20 into 20,000 into cos 1, the same value we are getting. So 2 lakh Newton meter. So tau is equal to 2 into 10 to the power of 5 Newton meter. So all the three methods we are getting the same answer. So we are able to do this in 3 different ways. We are getting the same thing. Okay.